बेटा आज का जो हमारा टॉपिक है दैट टॉपिक इज नथिंग बट इट इज एग्जैक्टली कॉल्ड एज बफर सॉल्यूशन. See, I was talking about one of the thing that there are certain solution which are required whose pH should not change as such. What I meant to say is there are certain solutions that are required in our day-to-day life where exactly we want that the pH should not change, right? Or I can say that suppose I have stored any solution. Suppose I was giving an example कि मैंने क्या किया, एक water को store किया whose pH is approximately maybe 7.2 7.3 approximately, not highly acidic, neither it is basic, approximately very near to, I will say, neutral. But somehow what will happen when the carbon dioxide which is actually being present in the air gets dissolved into it, you will find that it will form carbonic acid, and of course the pH will alter. Of course the pH will as such decrease to a little extent. I will say कि हो सकता है वो pH जो है, maybe I can say it may change into what, maybe 6.43 and so on. So what I eventually want to tell you is कि यहाँ पर pH जो हुआ वो change हुआ. So if the solution which comes in the contact either with the air or either if it will try to absorb carbon dioxide, it become acidic, right? This is one problem. Another problem is, beta, there is another problem. And if you try to store anything in a glass, suppose this is glass, right? This container is basically made up of glass. Glass basically contain, beta, alkaline impurities. I'll tell you, this glass basically contain alkaline impurities. So there may be a possibility that if you try to store any substance in a glass container, the pH will increase a little bit. But my point right now is that I want a solution whose pH should not change as such. Such kind of solutions are nothing but they are basically called as what buffer is. So first of all, what is basically a buffer solution is? Beta, if I am talking about a buffer solution is generally that which resists the change in its pH value with the addition of a small amount of an acid or a base. The best example is blood. आपका जो blood होता है उसका pH is 7.4 or 7.36 approximately, although you might have seen अब in a normal human being there are approximately 5 to 6 liter of blood. आपने देखा होगा एक normal human being में 5 to 6 liter of blood होता है. Though there are a lot of nitrogenous impurities that are being dissolved inside your blood, but its pH never alter, right? उसका pH जो होता है alter नहीं होता, वो 7.4 है 7.36 है, around about it remain the same. So my simple definition right now is, what is a buffer solution? A solution which resists any change in its pH, right, with the addition of a small amount of acid or base. That means practically whose pH will remain constant or it remain practically constant. That's basically called as a buffer solution. Now the question is, how many kind of buffer solution we have? So we are going to take up right now, that is types of buffer or types of buffer solution. See, if I am talking about buffer solution are basically divided into two types. When a single substance can act as a buffer, number one, or a mixture of a substance acting as a buffer, acting as buffer. So when a single substance is acting as a buffer, number one, or number two, mixture of a substance acting as a buffer. Although when I am talking about a mixture of a substance acting as a buffer, it is again being divided into two types. One is exactly called as acidic buffer, and the second one, of course, this is the acidic buffer, and the second one is nothing but it is exactly called as what? A basic buffer, right? We will be discussing in detail the mixture, but let's first talk about single substance acting as a buffer. So when I'm talking about a single substance acting as a buffer, we always have a salt of a weak acid with a weak base, which is acting as a buffer. I repeat, if I am talking about a single substance acting as a buffer, we always used to say that it is always a salt of weak acid with a weak base, right? So let's take up one of the example. If I'm talking about a weak acid, suppose one of the best example of weak acid is acetic acid. And of course, if I'm talking about a weak base, ammonium hydroxide. So when you try to club these two, the salt that I'm going to obtain over here is nothing but it is of course the ammonium acetate. So this is ammonium and of course acetate. So this is one of the best example of what a single substance acting as a buffer. I can give you other examples also, but right now uh, let's take up in detail the other kind of buffer solutions. As I was telling you, mixture of a substance acting as a buffer, उसका सबसे बेस्ट एग्जांपल बेटा मैंने बोला था, it has been divided into two type. One of them is nothing but it is the acidic buffer. So when I am talking about acidic buffer, the best part is solution of or solution mixture of weak acid plus salt of weak acid with a strong base always act as acidic buffer. I repeat, if you ask me that name the substance which will act as an acidic buffer, my example is solution mixture of weak acid, right, plus salt of weak acid with a strong base. For example, acetic acid is a weak acid. I repeat, acetic acid is a weak acid. Then I said salt of weak acid with strong base. This is this is acetic acid plus a strong base like ammonium NaOH, sodium hydroxide I have taken up. So when I am talking about acetic acid, which is a weak acid with the salt of weak acid with a strong base, so I'll be taking up acetic acid plus I will be taking up CS3CONA, which is of course the salt of weak acid with a strong base. I can give another example. Formic acid. Formic acid is again a weak acid. And when you try to mix it with a strong base, maybe a salt of weak acid with a strong base, so it will be NaOH. It will give you sodium formate. Sodium formate. The next example is about basic buffer. So if I am talking about a basic buffer, the best example, as I said, is nothing but it is first the substance which can act as a basic buffer. If I'm not wrong, it is solution mixture of weak base plus salt of weak base with a strong acid. I repeat, if I'm talking about a basic buffer, solution mixture of weak base plus salt of weak base with, as I said, a strong acid. So I will be taking up the example right now for this, as I said, with a salt weak base plus salt of weak base with strong acid. So let me take up the example. Weak base, ammonium hydroxide. Salt of weak base, I'll take up, but ammonium hydroxide, weak base, plus HCl. So the salt which is being formed from it is nothing but it is ammonium chloride. So one of the best example, as I said, is nothing but it is ammonium hydroxide plus ammonium chloride. Ammonium hydroxide plus ammonium chloride. I can take up another example, ammonium hydroxide plus ammonium nitrate, because here the strong acid I have considered is nothing but it is your nitric acid. I can take up another example, ammonium hydroxide. You don't tell me, sir, you know only one strong base, weak base. I can take up magnesium hydroxide also, but ammonium hydroxide is very commonly used, which is highly soluble in water. And I can take up here ammonium sulfate. Of course, sulfuric acid से बना हुआ. So this is about buffer solution. Now we will be taking up the buffer action. Beta, now we are going to start with what is basically buffer action is. अच्छा, जब मैं आपको बफर एक्शन की प्रॉपर्टी मतलब डेफिनेशन बताऊंगा ना, तो आप मुझे पता क्या बोलोगे? यू विल से सर इट इज ऑलमोस्ट द डेफिनेशन ऑफ व्हाट अ बफर सॉल्यूशन इज. So that will be helpful to someone who has just now joined the class. See, what is buffer action? As I said, what is buffer solution? A solution that resists the change in the pH with the addition of a small amount of an acid or a base. That's basically called as buffer solution is. मैंने बोला a buffer solution is that solution whose pH do not change with the addition of a small amount of a acid or a base. और अगर मैं बात करूं बफर एक्शन की, the definition remain the same. It is a property, or it is a property of any solution to resist the change in the pH with the addition of a small amount of acid or a base. That's basically called as a buffer solution is. So you may say, sir, it's the definition of buffer or solution or buffer action. Beta, the action of buffer solution is basically that also, that it won't allow the pH to change as such whenever you are going to add any amount of acid or a base into it. Let's understand one by one. See, when I have taken up the concept of buffer, that what are the kind of buffer we have, I thought I told you the first one is a single substance acting as a buffer. So I gave you an example, that salt of a weak acid with a weak base acting as a buffer, and I gave you the example of ammonium acetate. Now the question is, how does, sir, it act as a buffer? So let's start. How does it can act as a buffer? So I'm going to explain the first part. See, ammonium acetate is this, which is acting as a buffer, a single substance acting as a buffer. Since it is a strong electrolyte, once it is ionized, you will get beta excess of acetate ions, and of course you are going to get what? Excess of ammonium ions. I repeat, when you try to take up a single substance, ammonium acetate is a single substance acting as a buffer, you will have excess of ammonium ions and excess of acetate ions and excess of ammonium ions. Now the question right now is, sir, how does it will act as a buffer? Sir, if I'll take up case number one, case number one is when a small amount of acid is added. When a small amount of acid is added, you will be getting acetic acid. I said when a small amount of acid is added, it will act as acetic acid. So now, as I said, acetic acid is a weak acid. Since acetic acid is a weak acid, so what will happen now? The pH is almost same, or pH is almost constant. I repeat, pH is same or pH is constant, or pH will not change. In the same way, if I'll say case 2, if I'll add hydroxyl ions, so ammonium will react with hydroxyl ions to give ammonium hydroxide. So once it is giving ammonium hydroxide, again it is a weak base. This is a weak base. We know that this is a weak base. So if it is a weak base, that means again what will happen? The pH will remain almost constant. That means when this ammonium acetate will act as a buffer, you will find that there is no change in the pH. Now the question is, which is of course being asked in one of the exam, and it was, is it possible that a solution of sodium chloride can act as a buffer or not? Answer is no. Can NaCl solution act as a buffer? Answer is no. NaCl cannot act as a buffer. The reason is, there are two reasons I will discuss, of course. When I'm talking about sodium chloride is actually made up of a strong base and a strong acid. So of course it never act as what? It never act as a buffer. You may ask me why? Because I told you, when I'm talking about a single substance acting as a buffer, it will be a salt of weak acid with a weak base. So that's why it can't act as, because it is actually being formed from, it is sodium chloride is a salt of strong base and strong acid. Now I can explain the fact in that way also. Suppose NaCl, if it is ionized, it will give you Na positive plus Cl negative, and you will find that what will happen if I'll now say case 1, if I'll add hydroxyl ion into it, or a base is added, what will happen? It will form NaOH. NaOH means is a strong base. Is a strong base. Since it is a strong base, the pH will change. And in the same way, I'll say case 2. If I'm adding H positive, HCl is formed. HCl means what? A strong acid. So again the pH changes. pH change. So if the pH change, that means this substance can't act as a buffer. Now let me go to the next topic, and that's how does the buffer action of acidic buffer solution will work. How does the acidic buffer solution will work? Now when I'm talking about acidic buffer, we have acetic acid, we have sodium acetate. This is one of the example that we have taken up. One is acetic acid, another is sodium acetate. Acetic acid, whenever is ionized, it will give you acetate ions plus H positive ions. And sodium acetate, whenever is ionized, since it is a strong electrolyte, acetic acid is a weak electrolyte. That's why I have used the equilibrium ka sign. But if I have sodium acetate, it ionizes to give you acetate ions plus sodium ions. I repeat, it will give you acetate ions plus sodium ions. Now the point is, as per the common ion effect, if you see there is a common ion effect among them, the reaction will tend to go in the backward direction. So once the reaction will go in the backward direction, what will happen? The concentration of H positive ions will decrease, isn't it? Of course, the concentration of H positive ions will decrease. So what I want to tell you is, when I am talking about acidic buffer or buffer action of acidic buffer solution, you will find that by the common ion effect, the ionization of acetic acid is further suppressed in the solution. There are excess of acetate ions. Excess of acetate ions. That's the point, right? But the most important thing is we have less number of H positive ions, right? So now let us take up case number 1. Case number 1 is, what will happen if I'll add a small amount of acid? If I'll add a small amount of acid, what will happen? The excess of acetate ions will try to neutralize this, because it is going to give you what? Acetic acid. And as you know that acetic acid is a weak acid. So since it is a weak acid, the pH will not change. So that means it resists the change in the addition of what? An acid. Now, similarly, if you remember, I told you we have a little bit of what? H positive. Although we have H positive ions, although they are a little bit, but still we have small amount of, if suppose we'll add case number 2, if we add small amount of base is added. So what will happen? The H positive ions which are being present over here will try to counterbalance or neutralize the OH negative ion to form unionized water. Again, the pH will not change. That means this acidic buffer has just now resist the change in pH, resist the change in pH, of course with the addition of a little amount of acid or a base into it. Now the third example which I have to take up right now is, of course, buffer action. I repeat, buffer action of basic buffer. I repeat, buffer action of basic buffer. This is what I'm going to take up right now. So if I'm talking about basic buffer, we have what? We have ammonium hydroxide, which is a weak electrolyte, which ionizes to give you ammonium ion plus hydroxyl ions. And we have a strong electrolyte like ammonium chloride. So when we have a strong electrolyte like ammonium chloride, now what will happen? If it ionizes, it will give you ammonium plus chloride ions. Again, we have a common ion effect. Due to common ion effect, what will happen? The reaction will try to go in the backward direction, thereby decreasing the tendency of what? Or concentration of hydroxyl ions. So here again we will say that we have excess of, not so high, but we still have excess of ammonium ions that are present in the solution, and we have of course the hydroxyl ions also. Now again, what will happen if I'll add a small amount of base is added? What will happen if a small amount of a base is added? it will react with those excess of ions to form ammonium hydroxide, which is a weak base. So there is no change in pH. And in the same way, if a small amount of acid is added, what will happen? These hydroxyl ions will try to react with H positive and it will form unionized water. Unionized water. And once it will form unionized water, there is no change in the pH. यहाँ पर pH में फिर कोई change नहीं होगा.